The North American X-15 stands as one of the most significant experimental aircraft ever built, marking a decisive step between atmospheric aviation and human spaceflight. Developed in the late 1950s through a joint effort by NASA, the U.S. Air Force, and the U.S. Navy, the program sought to explore the unknown region of hypersonic speeds and near-space altitudes, where traditional aeronautical knowledge was insufficient. The aircraft was designed and manufactured by North American Aviation, a leading aerospace company of the era. The project originated from a 1954 research initiative aimed at studying flight beyond Mach 5. Engineers had to solve entirely new problems, especially aerodynamic heating. At extreme speeds, friction with the atmosphere could raise surface temperatures to levels capable of melting conventional materials. To withstand this, the X-15 was constructed using Inconel X, a heat-resistant nickel alloy, and incorporated a black coating to radiate heat efficiently, giving the aircraft its distinctive appearance. Unlike conventional aircraft, the X-15 used a rocket propulsion system. It was carried under the wing of a modified B-52 Stratofortress and released at around 13,000 meters altitude. After ignition, its XLR-99 engine burned liquid oxygen and anhydrous ammonia, producing immense thrust for a few minutes. This short but powerful burn allowed the X-15 to reach speeds exceeding Mach 6.7 and altitudes above 100 kilometers, entering what is often defined as the edge of space. The aircraft's design reflected its extreme mission profile. It was about 15 meters long with a relatively small wingspan, optimized for stability rather than lift. At very high altitudes, where the air is too thin for aerodynamic control, the X-15 relied on a reaction control system, small thrusters, similar to those used in spacecraft, to orient itself. The cockpit environment was equally extreme. Pilots wore full pressure suits, anticipating the requirements of future astronauts. Between 1959 and 1968, the X-15 completed 199 flights, generating an unprecedented amount of scientific data. Among its pilots was Neil Armstrong, along with other future space pioneers. One of the most remarkable flights was conducted by William J. Knight, who achieved the program's speed record of Mach 6.7. Another pilot, Joseph A. Walker, reached over 107 kilometers in altitude, clearly entering space by modern standards. The technological impact of the X-15 program was enormous. It provided the first real-world data on hypersonic flight, re-entry physics, and thermal protection, knowledge that directly influenced spacecraft design, particularly the Space Shuttle. The program also advanced fly-by-wire control concepts, stability augmentation systems, and pilot training for space missions. Even modern hypersonic research and spaceplane concepts trace their roots back to the X-15. In essence, the X-15 was more than an aircraft. It was a flying laboratory that pushed engineering, physics, and human endurance to their limits. Its legacy remains foundational in aerospace history, proving that controlled flight at the edge of space was not only possible, but repeatable and scientifically invaluable.